Remember to look up the camera.
It says I'm live. Sorry, we had a bit of technical difficulties there. No video. It might, that one, I couldn't get that one to work, so.
Okay, now you're live.
Can you hear me if you put your headphones on? Testing 1, 2, 3. Testing 1, 2, testing. You can hear me? Okay. I doubt anyone's gonna come. How do I even see who's here? I think you're the only one. It says, the little people thing up there says 1. Yeah. All right, well, we're figuring this out.
Yeah, I see you're one watching now.
Okay, yeah. Well, I figured no one would join. I just wanted to test it. Gonna have to reposition it slightly.
So share it on Facebook.
Wonder what quality it's in. Does it say that? It seems like it's pretty poor quality, but I don't know. I'm almost scared to say save it or send it to Facebook.
You should have a HMC t-shirt on.
I thought of that, but it's okay. Why? I'm not saying anything bad.
Because
I wear all kinds of t-shirts when I do my stuff. You really think?
Mhm.
I'm not doing anything bad. Share. Oh, okay. I can share it on Facebook or Twitter, email, embed. So that's kind of how it works. Okay. Well, we can end the chat.
Well, I just posted it on Facebook.
Oh, no. Really?
Yeah.
Okay. I was trying to see if I could do any kind of web sharing, but that might require streaming software.
You mean sharing stuff on your computer?
Mm-hmm. That might require, I've got streaming software that I was using for that game. Oh, I actually had streaming software I was using for Eve too. Was it Screencast Recorder? Maybe. Just yell at me if someone comes in. I don't think anyone's going to come, and that's fine. The quality doesn't seem very good, but maybe...
Maybe your camera sucks.
No, it's a 1080p camera. It actually looks better on yours than it does on mine. It's like backwards too. That's funny. Video editor. No. Not it. Now this won't automatically save to my channel, will it?
I'm gonna get it. Find out.
It says 0 now.
Oh, because I clicked off of it.
It doesn't matter. I'm thinking of shutting it down. I just wanted to do it for a test. Is my volume okay and stuff?
I'm not listening to you anymore.
Was it okay? Yeah, that's saying the wrong things.
Didn't realize that I left YouTube. Oh, see, I got an email. Christopher Moore's live now.
Ah, you're
I
kidding.
had it set to remind me, but it was must be linked to your old video or something.
See,
Yeah.
there's no way to say anything in there. When did that come?
4 minutes ago.
Hmm. Yeah, it couldn't create it because I think I did that one as a stream or something.
Live now.
Oh my gosh. That's too funny. Oh, there's 12 people here. Joking. Just kidding.
It's funny because there's a delay of just a few seconds. So you
There
say the
is
whole
there
phrase.
is 2 people now. Someone did come.
Oh.
Woohoo! You're the first one, whoever you are. It's probably one of your friends from work. That's too funny. Okay, you get the prize. Who are you? We'll have to come up with some kind of a prize for the first person to join our live stream. Hopefully my volume's coming through okay. They're not fessing up who they are.
Oh, they left.
Oh well, they don't get the prize. That's funny.
You're like, oh, a person.
Yeah. It's okay. I did not expect anyone.
So how do you screencast? You should, since you're live, you should try and figure that out.
What does screencast mean? Oh, there's another person.
Share your screen.
Oh. That I may have to do my other software that I was looking at. Hello, whoever you are. You might be the new first person. The other one left before they said hello. So we're trying to figure out the screencasting, get it working, and if you'd like to say hello, you get the grand prize for being the very first non-family member to join. They haven't left yet.
Maybe you should start talking about your wind turbine.
I will talk about the wind turbine, but I wanted a few people to talk to before I started just talking. Is anyone there? Stream status is good. You don't count, honey. You're like almost like an employee, but better. They're afraid to say hello.
Yeah, so just start talking, and if they leave, then they leave.
Maybe they're sending some feedback. No,
I'll manage your phone.
you can tell me if
I'll
some.
manage your YouTube.
Okay, well, what questions would you like me to answer about Harmony? I'll start with that. Since you are the one and only person here, you have my undivided attention. Oh, now there's two people. So there are some people. Hi, guys. Don't be afraid to say hello. Someone's going to get the grand prize for being the first non-family member to say hello in the Harmony VAWT live streaming channel. So I'm here to answer questions. I'm here to fill you in on anything that you're wondering about. Just waiting with bated breath to see somebody actually say hello or ask a question. Oh, we scared someone away. Any questions that you have, whomever you are?
Just start showing your stuff.
Yeah, but you know, these are just the little models. It was more a Q&A session, not you know. Here's a little Harmony. I don't think they're going to ask anything. They're shy.
So you have
They're
to
waiting for other people to ask. It's okay, we'll wait a little bit. You just posted the link. Are you shy? Obviously, you can't answer me if you're shy. Hello, we have another person there. I can't see who they are, so you have to say hello in chat, and then I can see you. But welcome to the Harmony Q&A session. I need some questions, and then I can answer them for you guys. So hit me up with whatever questions you have. It'll probably be maybe T will join and he'll harass me. That's cheating. You know all these answers. So So I've been working on Harmony for the better part of probably a year and maybe 3 months since I began the patent work. Lately, the past 4 months have been a lot more serious work in the machining and fabrication side of putting the large wind turbine scoops together. But the full-size prototype is not yet ready. That's what I'm putting together right now. I have all of the metal pieces machined. I have all of the gears printed. I've got both the big gears. These are really quite cool and large. They come through fairly well. 20 of these guys needed to print up, and they're quite strong. They mate into these gears as well. So the two of these will mate together, and then this is what controls the furling action on the turbines. Now they're not going to be furling continuously, open and closed as they're running. They're going to furl only when the RPMs get above a safe limit. So when you're in a storm condition or a high wind condition, then you would start having the turbines go from a fully open state, and fully open would be about like this, and they would begin to start closing in a little bit as they were spinning so that they could protect themselves. Just hoping, oh, the tower height. Hi, Andrew, you get the prize. You actually are the first person to ask something and say hello in the live stream. So if you email me with your information, I'll see if I can come up with something cute to send you in the mail, and you're going to get the first prize. So congrats. So the tower height. The really cool part about Harmony is the generator would be on the ground. So if you start at ground level, yeah, I think it's cool. Thank you. Thank you for not leaving and actually having the courage to say something. We had a couple people join and then they left and joined and left. But you're the first person. So Harmony, have you watched the videos? I can rehash stuff from the beginning, or have you seen any of the earlier videos of how it's going to work? Okay. So the generator is going to be on the ground. It's going to be on a concrete slab, or it would be, say, in your attic, and then inside of your attic, you've got the generator portion. The generator portion is, it's undetermined yet how big that's going to be. It's not going to be enormous. You're talking something probably the size of a dishwasher. So imagine a dishwasher sitting either on a concrete slab or up in your attic. Then coming out of that dishwasher, you would have your steel shaft coming straight up through out of the generator, and that would be the main driving screw that all the torque from the scoops are going to be transferred down through. So that main shaft is going to transfer all the power from the scoops into the generator. And you're only looking at, if it's on the ground, maybe 10 feet off the ground, so that as the blades are spinning, they're not whacking anyone in the head. The size currently I'm looking at making downstairs that I'm finishing up is the scoops from tip to tip when they're opened. When they're opened up, they're going to be from this tip to the other tip, would be about 4 feet wide, and each scoop is going to be about 1 foot tall. So there's going to be 5 scoop sections, and each scoop section will be offset from the next, and the next, and the next. So as it's going up, it's a helix. So it would be 5 feet total height, and then it would be about 4 feet wide. So if you're looking at it from a cross section, you've got it maybe 10 feet off the ground so that no one hits their head on these as they're spinning. And then the total would be 4 feet wide, side to side, 5 feet tall. Hey, Ithor, or I'm sorry, I'm not sure how to pronounce your name correctly. Thank you. I will try. Do you have any questions? And Andrew, did that answer your question? If you look at the one video, you'll actually see the full-size scoop as I open and close it. That's one scoop pair, and that is the correct size. Thank you. Can I ask what, Gustavo, what makes you say that about my turbine design? And obviously, any questions, guys, ask away. I'm here to answer questions, so have at it. Ask me any questions you want. Right. So definitely without the tower, you know, it's ridiculous how high you have to get before you get away from the turbulence. So I'm looking at deploying these as the first residential wind turbine that makes sense for people. Right now, you go out and start shopping for wind turbines, you're looking at $50,000, $60,000 for a wind turbine, and the payback on it can be as long as 30 years because you're only getting a little bit of money back on your initial investment. You also have a problem with the current wind turbines that are out there in the market where as they're producing power in low wind speeds going up to 5, 10, 15, 20 miles an hour, your production rate goes up. But as soon as it goes above the top limit where they are hitting max production, those wind turbines out in the market begin to drop off in their production because they have to start braking or they have to start dumping load to control their RPMs. With Harmony, once it's up to its max RPM and it starts sensing that it's going above its max RPM, all it does is begins to furl a little bit while it's still spinning at its top rated RPM speed. So if, let's say the top safe RPM speed for the materials we use is 400 RPM. As soon as Harmony starts sensing that it's going above 400 RPM, it'll start to furl just a little bit. You know, maybe it'll furl only 5% every 10, 15 seconds. And then it keeps checking its RPM as it's spinning. And if the RPMs are down below the 400 limit, now you're good. You don't need to furl anymore. So it'll keep running at that speed as long as the wind is consistent. If the wind picks up even further, it would furl down more. And it would, who would have thought the 10th Crusade? Basically, the furling action will continue until the RPMs drop to a safe range, and then it'll hold at that level as the wind is high. As your wind begins to drop off and die, then it would start opening back up to fully opened. So the really cool thing about Harmony is, where I was saying the other wind turbines have a line they're coming across with production, they go up to their peak production, and then when they hit their peak production at, say, 25 miles per hour wind or whatever, it's really high what they have them rated at. That's how they're trying to pull you in and suck you in and say, oh, we can make all this money for you because you've got the ability to produce 4 kilowatts of power, but it's in a 25 mile an hour wind. We don't have 25 mile an hour winds here. I mean, other than when you have thunderstorms. We've got an average of 10 mile an hour winds in Pennsylvania where I live. I'm looking to make, and we have a crappy state for wind, really. So I figure if I can make this profitable for Pennsylvanians, it's going to be profitable for any state in the United States and certainly overseas and so forth. So where those other turbines go up and they peak at like 20, 25 mile an hour before, as they peak at 20, 25 mile an hour, as soon as you get above those wind speeds, now their production rate drops off drastically because they have to start closing down, dumping load, using a mechanical brake, all different kinds of things. Harmony just furls up a little bit, but it keeps spinning at its top rated speed. All right, wind speed here isn't strong enough at the ground. Andrew, where are you at? What state? The prices that we're looking at, Wolfgang, we're probably thinking there's a lot of work to be done. You know, prototyping, moving into production is a pretty big step, but I'm trying to keep it under $8,000. Okay, Alberta, is that Canada? I'm so bad with geography. All right, Andrew, I can't imagine that your wind speeds are less than, 5-10 miles an hour. Are they really, is it really that calm that you don't have any wind 5-10 miles an hour? Hey, Terry, I figured you'd be in here to harass me. Yes, it's going to work. How much it's going to produce is the big question, and that's what I'm really excited to get the first prototype. Maybe I'll do live stream when we fire up the first prototype. That would be pretty cool. I'm literally days away from getting the prototype. I'm starting to put it together right now. So let me make sure I didn't miss any. Ihor. What was Ihor asking?
Size, like the one you had in your hand.
Okay, let's say that the one you have in your hand. Oh, man, this is just a toy, Ihor. This little guy's a toy.
Want me to get a scoop from down there?
Like a full-size scoop? No, it would be so big. They've seen, you guys, the videos where I'm standing in front of the full-size scoops and opening and closing them, that is the full-size scoops. They're about, when they're fully opened, they're about 4 feet wide from tip to tip and 1 foot high. So Ihor, the real, true, full residential size turbine is going to be about 4 feet wide, 5 feet tall, if you're looking at it from the side. And then, of course, you would want it maybe 10 feet off the ground. So as it's, as it's spinning, you're not whacking anyone in the head. If you mount it on the roof of your house, then all you would have to do is have the pole coming out of the generator through your roof, and you would only have the scoops on the pole sticking out of your roof. You don't need the generator sticking up there on your roof. That could be in your attic, which is pretty cool when you think about it. A smaller hole in your roof, and aesthetically, it really would be more of a work of art than it would be some ugly industrial thing generating power. I'm looking at, if we can keep the price under $8,000, and I would love to be producing 1,000 watts of power in a 10-mile-an-hour wind. If we hit those targets, then you're looking at a 5 to 7 year payback, and you'd have all your money back in electric savings on that wind turbine. And that's heads and tails above what anyone else can do right now. Because are there holes in the scoop to hold them together? Yeah, there's certain mounting holes and all kinds of things that, as I'm building them, to hold them together, Terry. Definitely. So, Andrew, you could most certainly put this up on a tower. There's nothing stopping you. It's not like you can't use this with, or I'm sorry, let me back up. You can most definitely use it with a tower if you want to get it up higher. There's nothing that I'm going to care about or our company's going to care about. You put it up as high as you want. We're just trying to save the average person from having to put some big, ugly, crazy tower 80 feet, 100 feet in the air to make power. So right now, you're putting a tower up there because you're trying to supply your whole house with the power you need from one wind turbine. These are so pretty and they're so cool. Who cares if you put 2 or 3 of them on your property and they're at ground level or they're on your roof? Now you've got 2 or 3 of these little guys. They're like a work of art, and you're now making all of the power needs that your house is using. So throughout the day, it's not like you can run your whole house off of these. They're just offsetting your meter as it's spinning and using power from the grid. Whenever the wind is going, you're putting power back into the grid. So it's kind of like a net loss of 0 from your meter, because your meter would be even spinning backwards in cases where you're making more than you're using if you have a grid tie inverter. Okay, so you have 12 kilowatt of solar. This would be able to tie right into that source. It's making DC just like your solar. Is your solar pushing 24 volts or 12 volts into your system right now? Or do you have it going directly into grid tie and converting it to 110 volt? Okay, so you have 48 volts. Do you go into battery banks or something? Okay, yeah, you're going into lithium battery banks. So like a Tesla Powerwall or something at that point. This would be the exact same thing. You would take your power produced from the wind turbine and be able to plug it right in as an additional source for your 20 or your 48 volt power array. And that'll allow you to charge when the sun's not shining, but the wind's blowing. You're going to be able to dump power into that array just the same way. So batteries, some sort of storage. Did you consider some techniques? Yeah, IHOR, we're definitely looking at coupling with companies to do storage, because in my opinion, that's the only way that it really makes sense. Even if you have a small battery or capacitor bank on the back end of these turbines, think of it like a UPS for your computer, but in reverse. It's getting power dumped into it at really crazy rates. It's going up, it's going down, up, down, up, down. But out of the back end, out of the sort of battery bank or capacitor bank, you have a straight line coming into your house, which is nice because then you're not getting fluctuations on the grid. If you have every single person in an entire city has these things, you'd have problems with the grid going up, down, up, down, up, down all the time. But if you have a capacitor or a battery bank on the back end, then it's leveling out those charges so that you're getting a nice flat line coming across. It's the problem with our grid in general. Every time they build a 6 megawatt generator, a wind turbine, they have to put a fast acting gas turbine on the back end that costs several $1,000,000, just so that between the two, as the one goes up, the other goes down. And it's a huge draw on the entire grid the way they're doing it right now. They should really have a battery or capacitor bank on the back end of every solar array, every... Okay, fill me in, you're saying not anymore. I'm not sure what the not anymore is referencing, so you have to fill me in there. Oh, weights on a tower. Yeah, I've seen, right, they're using the gravity as the battery, but then you've got to have, there was even a really cool design that I saw where you've got a sort of crane in the middle of these very large, heavy Lego bricks, and it's lifting them up as it's got power surplus. It's lifting them up to heights and stacking them on its own tower. Yeah, they're freaking awesome. I totally get it. But the complexity of doing that is where the problem is. So I think capacitors are where it's really going to be. Look at capacitors right now. And 10 years ago, you couldn't even get a 1 farad capacitor for probably under $50,000. Now you have 3,000 farad capacitors that are smaller than a can of soda. And they're looking at, in just a few years, you're probably going to have 10,000 farad capacitors in that same size. I believe capacitors are probably where it's going to be for renewables, dumped directly into capacitors, because they're constantly refilling the capacitors. Capacitors don't do well holding storage for a long time. But then out of the back end of the capacitors, you could be feeding the grid with a nice straight net positive gain onto the grid. And whether that's residential houses each individually doing that, or larger, 1, 2, 3, 10 megawatt wind turbines doing it, or solar arrays, it doesn't matter. The boost on the grid in general would be positive at that point. Right, the molten metal batteries, all of that stuff. It's amazing, but they're trying to think so large and so big that they build themselves into corners in a lot of ways. If they just put a small, reasonable size one on the back end of every single wind turbine out there and every single, small set of solar arrays, think of how nice that would be, because then you would have the ability for it to radio, through networking. It would say, ooh, I'm running low on power. I'm down at 20% reserves. I'm going to power down right now. So as it powers down and stops contributing so it can fill back up its batteries or capacitors, the grid already adjusted and took over by other ones coming online. And you have kind of this network all talking and integrated to adjust the nice steady line that the grid needs, instead of having these quick reacting, the gas turbines and everything on the back end that have to do stuff. We're using so many fossil fuels, burning so many fossil fuels on the back end just because we have to keep balancing whenever the wind or the sun is going up and down. Any other questions that you guys have? In the molten batteries, yeah. Andrew, it's amazing technology. There's no doubt about it. I just think it's a lot more than you really need. It's like using a sledgehammer to kill a fly. This problem that we have is so simple. All they need is some very simple capacitor or battery technology on the back end of each of the individual units out there, and you'd have a solution in place 10 years ago, but they didn't do that. Not sure what you're asking, Ihor. So these units, the 4 feet wide, 5 feet tall residential units, I'm not sure yet. Andrew, that's what I need to finish building them. I'd love to say that it's producing, 1,000 watts and 10-mile-an-hour winds, but I can't say that until it's built. That's the whole point of building the prototype, testing the prototype in various wind speeds and conditions, and then I'm going to share all of that information with you guys. Whether it's good, whether it's bad, whether it's amazing, or whether it's horrible. I'm not going to hide anything or fudge any numbers. If it's bad, it's bad. And if it's bad, I'll improve it or I'll make it larger so that it, gives us more power output, whatever. I'm hoping, I'd love to have those units that are 4 feet wide, 5 feet tall, 5 scoop pairs, producing about 1,000 watts in a 10-mile-an-hour wind. That would be wonderful. What do you want me to compare heights to? And Ihor, what did you mean? Does someone know at what point Sadaway?
Sadaway is the MIT guy who made the liquid metal.
Oh, okay.
But I don't know what the question was.
I'm not sure what his question was. Oh, Donald Sadaway Technology on liquid state batteries. Yeah, and I'm not in any way saying anything negative about that technology. I'm just saying it's a lot of infrastructure to get that up and running, and they're doing it on very, very large. I've seen it on really large mirror arrays where they're using the liquid salts, really is what I've seen. They're heating up the salt using heat exchange to then drive the turbines. So Andrew, you're saying compare heights, compare power generation, same battery. Can you ask the question a different way? I'm not sure what you're asking, Andrew. Is my video feed coming okay to you guys? Is it coming through okay? Oh, Andrew was answering Ihor. Okay. Yeah. All right. So Andrew, right. But see, at different heights, all you're doing is getting different wind speeds at different heights. If you put this thing in a wind tunnel and you run the wind tunnel at 10 miles an hour, that's going to give you an apples to apples comparison. If you then put Harmony inside of that wind tunnel and test how much it can output with the same type of horizontal axis generator, and you put it in the tunnel at 10 miles an hour, you can't really say, oh, well, mine's going to produce the same as someone else's up at 300 feet or something. That doesn't work. It's really in a consistent miles per hour wind speed that you're going to be able to tell what the numbers are. Where you get that wind is up to you entirely. Whether you put it up 300 feet or keep it at ground level, that doesn't matter. Yes, the wind is more turbulent at ground level, but a generator using scoops like this is going to be far better at picking up that wind, turbulent wind at the ground level, because this can handle the turbulence much better than the horizontal axis wind turbines can handle that turbulence at ground level. So, you really don't need to compare the different heights. You would just compare wind speeds. At this wind speed, we make, 800 watts of power. At this wind speed, we make 1,200 watts of power. At this wind speed, we make, 1,500 watts of power. So that's where your power output curve comes from. And that's what I'm so excited to be able to provide for you guys, in a very short amount of time here. I'm coming down to, like I said, literally starting to put this thing together this weekend. I have all the components built now. So not sure if anyone's in Pennsylvania and wants to come over and help put them together, but it would be cool. Yeah. So Andrew, I'm looking to have some really nice data here after I get the turbines together. I'm going to see if I can get into a couple wind turbine tests, not wind turbine, wind tunnel tests. I'm not sure if there's any in the area that would allow me to do that, but it'd be great. Otherwise, I have silly sort of backwoods means of gathering the data. The cart that I'm going to be using that is going to have the generator built into it, I'm just going to be using an off-the-shelf generator right now. It's a 3-phase 1,000 watt generator. I'm probably going to do a 4-to-1 ratio. You know, a tooth pulley or V pulleys have a lot of friction, so I probably won't do that. But every 1 rotation at Harmony on the blades would translate to probably 4 rotations at the generator. And in a 10-mile-an-hour wind, I've computed that Harmony should probably be spinning at about 18 RPM. So when we take that 18 RPM up to, you know, times 4, you're looking at 80 RPM at the 18 RPM seems awfully low. Maybe that might be in 5-mile-per-hour winds. It might be up in the 30s in the 10-mile-an-hour wind. I'm sorry if I'm remembering that incorrectly, but again, it's speculation at this point until I see the real data. Yeah, bicycle belt. The tooth belts like I have on my milling machine and stuff like that, they're really nice and they're low friction. So something like that to transfer the power from the main driving shaft on the scoops to the generator is what I'm after. Probably a 4-to-1 or 5-to-1 ratio, somewhere in that range. If I have to up it, then I'll up it. It's no big deal. That's just getting different pulley sizes. And then basically starting to gather numbers. This thing will be small enough that it's kind of funny to think about, but I could strap it into the back of my truck and drive down the road at 10 miles an hour, drive down the road at 15 miles an hour. Yeah, it's not a wind tunnel, but it's going to give you a pretty good indication of what your production rates are. And driving down the road, someone inside on the passenger seat could be watching the data coming through on a laptop computer or whatever, and you could get some really good numbers that way. We've got a place near us that has a pretty tall cliff with lots of good wind up there. I plan on taking it up there and doing real wind testing off of the cliff and, you know, just seeing how good the production rate is. Now that's going to be turbulent wind and varying wind speeds and so forth, but it'll still give us nice feedback. Any other questions? All right, well, I've probably overstayed my welcome here with 43 minutes. I was really expecting only to do 1 or 2 questions here and there. So you guys have been wonderful. Thank you for joining and thank you for asking the questions that you have. I'm going to try and start doing more live streams and question and answer sessions as we get Harmony built and start to show Harmony. There have been a lot of naysayers. Oh, this is a scam because you don't have any data. I don't even know why people would say that. It's just simply not built yet. So I'm working on building it. And yes, it's taking a while, but it doesn't mean it's a scam. It's just taking a while. So, spread the word. Let people know this is out there and let people know I'm a real down-to-earth guy working on building this. I've got a lot of people, friends and family right now helping to do this. And we've received some funding from Pennsylvania, Ben Franklin Technology Institute. So they've looked at the technology, they know it's a real thing, and they know they've seen my shop and what I'm capable of. It's just a matter of putting the time in to actually do it. So I am really, really close to getting the prototype together now. I have all the parts pretty much built, and now it's just a matter of getting everything put together and put the scoop arrays together, lock it all in, and then we can start seeing how it spins in the wind and what kind of production rates we get. So we're 45 minutes in here. If there's any last questions, I'll answer them. Otherwise, I'll sign off for the evening, and thank you all for joining. And who was the very first guy? Was that Andrew? Let me scroll up here. Andrew, like I said, email me. If you send me your information, we'll come up with a cute little gift to send you, since you were the first one brave enough to ask a question in chat here, okay? My email is in... I probably should post that. It's you can send it to Chris, CHRIS, I'll put it in here, at creatingmore.com. There you go. Send me your information and we'll send you some, I don't know, we'll come up with something cute to send you for being the first one who was brave enough to say hello in chat and join us for live stream. So that's my email address, guys. All right. Thank you very much. Ihor, if you're still on. Andrew, thank you. Send me that email and we'll go from there. Take care, guys. How do I end this? End stream. Are you sure you want to end? Yes.